So this is looking at how we calculate pH. This one is looking at pH of a 0.01 HNO3 solution. HNO3 is your nitric acid. And if we were to do the dissociation reaction, is HNO3, H plus NO3. These are all aqueous. I've been leaving these out. Okay, so then you know that you have a concentration of 0.01 molar. First thing first is that once you write your dissociation reaction, make sure that is balanced, because there are some acids that will have two H's in their chemical formula. But since this is 1 to 1, this is all balanced. And the reason why this is important is that since HNO3 nitric acid is a strong acid, all of this HNO3 will get dissociated into that. That means it will get broken down into that. What that means is that whatever concentration you start off with the acid is exactly the same for your H plus, and also exactly the same for NO3, because you have complete dissociation. Why that is useful? Because now you have the concentration of your H plus, and then you can plug that into your pH formula, which is pH is equal to the negative log of H plus. This is really convenient. Since it's a strong acid, it's very convenient because you don't have to use any algebra, because you can just assume that it's a complete dissociation. So then if you plug that concentration in 0.01 molar, and then try this on your calculator. So I'm going to put log 0.01. Sometimes I like to put log first. Once I do that, I get an answer of -2. I know because since there's a negative in front of the log, it looks like this. A negative on a negative will give me a 2. So this will give me a pH of 2 for that nitric acid. That's how you calculate the pH. So the next question is, what if you have the pH and can you get that from a pOH? So how can you get the pH from a pOH? So what pOH is exactly the same as pH, but you're looking at the power or the negative log of your hydroxide ion in this case. So pOH is really just the negative log of OH minus. That's your concentration. So you want to relate your hydrogen ion with the hydroxide ion, because they're actually really related, just like a seesaw. So if you think about acid and base as in a seesaw, one side has your H plus, the other side is your OH minus. If one side tips over, that means that if you have a lot of H plus, your OH minus is actually very little. That's how your acid and base pH scale works. So if you look at water, water is neutral. That means it has exactly the same amount of H plus is equal to OH minus. And if you look at the numbers of what we have for it, you have 1 times 10 to the negative 7, 1 times 10 to the negative 7. And when we multiply these two up for our Kw, right here, this multiplied by that, this will equal to 1 times 10 to the negative 14. Right? The 7 and the 7 are added together. If you were to take the pH of that, you notice that you will have 14. That's the total. That's if we were to combine both concentrations. So you can actually break down that pH equation to 14 is really equal to your pH plus pOH. So how that is useful is that if you were to have a pOH here, in this case, if you were to have a pOH of 3.4, so here's you have 3.4, this is the total pH. What is my pH? Well, you just put it into this equation and then solve for pH. So subtract 3.4 here, subtract 3.4, this will give you a pH of 10.6 if your pOH was 3.4. Okay, so in this question you can actually get two things. pOH is 3.4, pH is 10.6. That's how we do it. If we were to go back to the original one about nitric acid, if pH is equal to 2, what's the pOH? You can plug it in. I'm just going to do it right here. 14 is equal to pH plus pOH. So that this is 2 plus pOH, and then 14. Solve for pOH. So if you subtract 2 from both sides, you will get a pOH of 12. That's how you solve that. All right. What if you were to calculate the ion concentration from pH now? So this one is basically doing the inverse of this. So if you look at your calculator, behind your log, you actually have this anti-log. So it's usually the second function of your log one, which is your 10 to the x. So if you're given a pH, let's look at this example of pH of 8.3. What is the H concentration? The answer is this, but let's punch it in the calculator. So right here, we're looking at this equation of H plus is equal to anti-log of negative pH. So don't forget there's a negative sign in front of your pH. So on your calculators, try this out. When you have a pH of 8.3, you're putting it like this. I did my second function, negative log, and then I put in negative 8.3, and then I press equal. I don't know if you can see from the screen, but once you have the negative, you will get this answer of 5.0 times 10 to the negative 9. That's the concentration of my H plus. Okay, so that's how you go backwards from that. So hopefully this pH calculation makes sense. So hopefully that video has helped you. Thanks for watching.